Ready too. I'll get it queued up here and we're off to go. Let me just share my screen. Can you see the PowerPoint?
It's loading.
Okay.
Yeah, we have your screen now.
Okay, so you can see careers in engineering.
Yeah, you have there you go. Now your slideshow started.
Okay. So hi everyone, my name is Rob Lacera, and I have a presentation to show you today on careers in engineering. Just get this rolling here. There we go. So I'd like to introduce myself a bit. As I said, my name is Rob Lacera. I live in Haddon Heights, New Jersey. I have over 35 years experience in the engineering industry for both owner-operator companies and engineered procurement and construction management, otherwise known as EPCM firms. Basically, the work that I do revolves around project management and program management. I've also done some quality management for engineering systems, and I started out my career as a process engineer. I currently work for a company by the name of Jacobs Engineering. Jacobs is a 60,000 person worldwide engineering firm. The office I'm at is in Mount Laurel, New Jersey, and I've been with Jacobs for about 25 years. Matter of fact, I just celebrated my 25th year anniversary there. I have an engineering degree in chemical engineering and an MBA, both from Drexel University back a couple decades ago. I'm a registered professional engineer in 2 states. I'm also an adjunct professor for chemical engineering at Rowan University, so I do some teaching on the side as well. I do have my state of New Jersey teaching certification in mathematics, engineering technology, and chemical technology. I'm also the CEO of a company called Stembridge, which I'll talk about very briefly in just a second. Essentially, this engagement that we're doing is really through the company called Stembridge. Stembridge is a virtual network which connects STEM academia, namely yourselves, with industry subject matter professionals such as myself to try to bring into your STEM classroom some real world engagements to give you, just to augment your book studies with some real world type engagements. I do not work directly for Project Lead the Way, but I am familiar with Project Lead the Way, and that's how I met Mr. Knaus. I'm on 3 Project Lead the Way advisory boards. One of them is your school, Deptford High School. I'm also on the Camden County Technical School and also Cape May Technical School advisory boards for Stembridge. So that's a little bit about me. As I mentioned, the company that I formed is called Stembridge, which is a way in which to bring industry professional STEM subject matter experts, people like myself, into your classrooms, the STEM classrooms, via online web conferencing. So the premise is that I do this by web conference. I will come in sometimes to do it personally, which is probably the best way to do it. But the premise is to do it online, and that way travel costs and travel time and logistics of that type of thing can be taken off the table. So hopefully this will bring you some real world expertise. I have about maybe a 30-minute presentation here, and then I'll field some of your questions. If you'd like, I will send this presentation to Mr. Knaus. There is a link here which tells you all about Stembridge, and there's also a website that Stembridge has if you'd like to look into it a little bit further. So today's agenda is I'd like to talk, do some introductions, which we did. I would like to ask you though, while we're doing introductions, maybe I know there's only a few of you there, but maybe you could tell me some of the disciplines within engineering that you might have an interest in. So perhaps you can tell me a little bit about the types of interests you have, and I can tailor the presentation in that direction.
Biomedical engineer.
Biomedical engineering.
Biomed, okay.
Aeronautical engineer.
Aeronautical, aerospace.
Okay, we're going to talk a little bit about that.
Mechanical?
Okay.
Not sure. That's about it for now.
Okay. I should have asked what grade are you folks in? What year in high school?
They're all in Mr. Fishman's, Dan's Principles of Engineering class to 10th grade.
10th grade. Okay. All right. So thanks for giving me that background. I appreciate it. I'm going to talk about what is an engineer. I'm going to talk about some common engineering disciplines and careers, and then I'm going to talk about some alternative discipline engineering careers. I think you'll find this very interesting. There's some avenues that you could go into and some careers with an engineering degree, but they're not directly engineering type jobs. I think you'll find that interesting. Something that's always very interesting, of course, is the salary slide that I bring up. We'll talk about some of the local schools. There's some helpful links in here, and as I said, I'll leave this presentation with you folks, and you can look at them at your leisure and then answer any of your questions that you might have. Oops, sorry. So what is an engineer? Engineer is actually derived from two Latin words. One is enginere, which means to contrive or devise, and ingenierium, which means cleverness. So engineering really is trying to develop something in a very unique way. So these two Latin words are very apropos for where the word engineer comes from. It's kind of interesting. An engineer applies scientific knowledge, math, and ingenuity to develop solutions for technical problems, and they design materials, structures, and systems while considering limitations imposed by practicality, regulation, safety, and cost. So I'll give you an example. I'm a project manager of a job right now for Honeywell, and we are doing a retrofit to one of their plants in Baton Rouge, Louisiana. It's a refrigerant plant, and they want to double the capacity of the refrigeration capacity for this plant. So we're doing what's called a retrofit project, meaning we're taking an existing system, an existing process, and we're basically making it larger. We're adding equipment, we're adding piping, we're adding instrumentation, we have some new structures to put up, and there's some new electrical systems and so forth. So while it sounds all very straightforward, there are many, many limitations that are imposed on this job. Things like schedule, different codes that we have to apply to, the cost, the overall cost that we have to adhere to, the quality of the work that we do, how to do it safely. Safety is a very big component of these projects nowadays. Large companies measure their safety metrics, and they take it very seriously, as they should. So we have a lot of these limitations imposed on us, and as engineers, we have to use this cleverness word that I mentioned up here to try to figure out how we're going to get around all these limitations that are imposed on us and get this project done on time, within budget, for a very high quality. So engineers are versatile minds who create links between science, technology, and society. And Steve Jobs, the founder of Apple Computer, said back in 2001 that innovation distinguishes between a leader and a follower. So what kind of skill sets do engineers have, and what are some good skill sets to have? So obviously the easy one is the technical skills. You have to be a good technical person. And one of the things that I mentioned to the students at Rowan that I teach is, and generally I'm teaching seniors. So these are students, these are young men and women who are getting ready to go out and start their careers. And what I tell them is this: I say, you're all going to graduate with whatever, a 3.2 to a 3.8 GPA. You're all going to have basically the same type of technical skills, give or take. Some are going to be, a little bit better students than others, but for all practical purposes, they're all going to have gone through the same classes, they're all going to have gotten the same material, and they're all going to be roughly the same from a technical level. So I said, you need to distinguish yourself from the rest of your colleagues. And these skill sets that you see here are really the distinguishing factors for engineers, because again, they're all pretty much the same from a technical level. So they need to have very good problem-solving skills, analytical thinking, multidiscipline teamwork. I work with a group as a project manager of disciplines like process engineers, mechanical engineers, electrical, instrumentation, civil, structural. So you have to work in a multidisciplinary environment. You're working with disciplines other than your own. Sorry about that. Other than your own, and you need to know how to work with other disciplines well. Let me see. Did I skip a slide here? I'm very sorry. There we go. This thing's a little touchy today. Okay. The biggest skill, though, I think, and if you have one takeaway from this presentation, hopefully this will be it, is communication. I think if you have good communication skills, meaning written and oral communication skills, if you have good collaboration skills, I call this the 3 C's: communication, collaboration, and coordination. You're going to go a long way as an engineer, and the reason for this is generally technical people, particularly engineers, and of which I am one of them, a lot of times don't have very good communication skills. We're very technically oriented. We tend to like to operate, in our own little world, if you will, and we don't sometimes communicate well with others. But having that as a good skill will distinguish you from many of the other engineers that you're working with. So I encourage you to polish your communication skills, learn how to get up and talk in front of people and give presentations. You're going to probably do a lot of that if you're an engineer. You need to be comfortable doing that. And this is a very big skill to work on. It's one of the softer skills. People think it's all about the technical side, but it's really not. You need to really be able to communicate and work well with other people, and that will really make you go far in the world. I guarantee you that. You have to be able to think outside the box and have innovative thinking skills. You have to be very organized, and sometimes in the engineering world, it gives you an opportunity for travel. As an example, as I mentioned, Jacobs Engineering is a 60,000 person firm. We have jobs worldwide. If you go to jacobs.com, there's a section there for job opportunities. And if you go in there, you'll see that there are job openings with Jacobs all over the world. Now, they're not necessarily for entry-level people, like if you're coming out of college, but a lot of them are. And some of them are in other countries. So if you would like to travel, it might behoove you to hook up with a large company like a Jacobs, and you can actually see the world on their nickel and travel a lot, which would be kind of a neat thing to do. Recently, I went to India for Jacobs. We have an office in India, and the job that we're doing right now, we're partnering with that office. So I had to go over to India for a couple weeks, and it's kind of neat to see other cultures and meet other people. So that's kind of a nice side benefit of the job. So engineers can work in groups, or sometimes you work alone, but most of the times you're working in groups. We're looking to make a difference in the world. Generally, you'll see that engineers have a lot of passion and energy for what they do in life. Unfortunately, engineers are sometimes stereotyped as geeks or nerdy, but that's not really true. Matter of fact, engineering is a pretty cool curriculum, and if you think about it, really everything that you come in contact with during the day somehow, some way relates to a STEM, a science, technology, engineering, or math discipline somehow, some way. So being involved in this type of world, this type of environment is, I think, really neat. Just recently in Paris, they finished up a worldwide conference about how to reduce greenhouse gases in the world. They came to some kind of agreement. Well, all that has to do with science, technology, engineering, and math, about alternative fuels and alternative uses of energy and cutting down on carbon footprint. And I just think that's kind of a neat arena, and there's so many opportunities out there right now, as we'll talk about in a minute, of why salaries for engineers are a little on the high side, is because the supply and demand is out of balance. There are a lot more engineering jobs out there than there are engineering graduates. So that's good for you if you're coming out as an engineer. You have more job opportunities, you have more job security, and you also tend to make a little bit higher salary because of the supply and demand curve. So think about these type of things if you're considering a career path in engineering, and it'll try to help you channel your way into which discipline you might want to get into. Did you know that there's 2 U.S. presidents who were engineers by trade, by discipline? Does anyone want to take a guess who they might be?
Jimmy Carter.
She got it. She got one of them.
Which one?
She got Jimmy Carter.
Well, she got the hard one. Jimmy Carter is one of them, so I can't click on this yet because the first one is somebody different. I'll give you a hint. They named a dam after this president.
They got it.
Hoover Dam, right?
Yep.
So Herbert Hoover was a mining engineer and very good on the Jimmy Carter. That was pretty good. Most people don't get that one. Jimmy Carter actually was a nuclear engineer. So I don't know what we had, maybe 40-some, 45, 46 presidents. I don't know where we are now. Well, two of them had an engineering background. But here's an interesting stat I find. If you took all of the CEOs, the chief executive officers of all the Fortune 500 companies in the United States, so these are the biggest 500 companies in the United States, the most predominant educational background of those CEOs is engineering. Now, most people would have guessed, well, it's probably marketing or finance or management or something like that. But interestingly enough, it's engineering. And these are people who are running the biggest companies that we have in America. As I mentioned before, you get a lot of job security because currently there's a shortage in STEM graduates, and that's going to be the case. As a matter of fact, that gap is going to even widen more over the rest of this decade. So you folks as sophomores, so you have about 6 years before you'll be coming out. So you'll be 2021 in that time frame. There's going to be a huge need for STEM graduates, particularly engineers. Then you're going to be in high demand. You're going to have a lot of job security. I know for a fact that some of the seniors at Rowan who are graduating last year had multiple job offers for engineering, which is great. Then they got to pick and choose between a couple of different job offers. So it's a very good arena to be in over the next couple of decades. So let's talk a little bit about some of the common engineering disciplines. As a matter of fact, I'm going to scroll through the animation here and just put this up on the screen for you. Whenever you talk about engineering, I call these the big six, if you will. I mean, the first four are the big four: civil, chemical, electrical, and mechanical. Those are the ones you kind of hear a lot about. Environmental and industrial nowadays, too, you hear a lot about these types of engineering disciplines. But as you'll see, with the world changing conditions, some disciplines are now becoming more popular. So sustainability and energy engineering is becoming very popular. One of the reasons is what I just mentioned about how we really do need to put a lot of work into our carbon footprint and greenhouse gases, or else our children and our children's children are really not going to have a very good environment in which to live. So as an engineer, if you were interested in sustainability engineering, and I can tell you that Villanova University around here, for one, has a very good sustainable engineering program. Matter of fact, the reason I know that is I started that program a couple years ago. I never did finish it, but it's a 10 course program, a master's course in sustainable engineering. So if you're interested in alternative sources of energy like wind energy and solar energy, they're even harnessing now the tides. So they're putting turbines beneath the ocean, and as you know, the tide goes in and out. Well, as the water flows through the turbines, it turns the turbines and generates electricity without any carbon footprint. So just think about that. They're harnessing basically the ocean currents and tides to generate electricity because it doesn't burn fossil fuels and doesn't pollute the air. I mean, how cool is that? Tides are free, right? Solar energy, so the sun is free. I mean, yes, you need to build solar panels and you need to build wind turbines, but the driving force, the motive force is free, and we can help clean up the environment by harnessing some of that energy, and that's where engineers come in. So kind of a cool arena, I think. Another one that's getting to be bigger, and somebody mentioned this before, is biological or biomedical. And that is going to be big over the next couple of decades for sure. I know your school has a biochem or a biomed program for Project Lead the Way. So you have that tracked at your school, which is great because it's an up-and-coming discipline for engineering. Interestingly enough, petroleum engineering is still very popular. Now, what you hear right now, what do you hear? You hear crude oil is down around $35 a barrel, which is almost unheard of. You know, a gallon of gas now I saw today was about $1.70 a gallon. I never thought I would see that again. because crude oil was up over $100 a barrel really not that long ago. Petroleum engineering, though, they are one of the higher paid engineering disciplines coming out of college. And a lot of this has to do with the drilling and what they call the upstream production of crude oil, getting the crude oil and the natural gas out of the ground in a sustainable fashion is very critical and popular these days. Aerospace engineering is another up-and-coming type of discipline that you don't hear a lot about. Nuclear engineering is actually making a comeback. Nuclear was not was out of phase or out of vogue for a while because of safety regulations. But what's happened is the new nuclear plants are being designed in a much safer fashion. They have better fail-safe and shutdown systems. And not only that, but some of the new Type 3 nuclear plants actually use the spent fuel rods from older nuclear plants, which have always been a problem. What do you do with these fuel rods that really never they never dissipate? So there's always some waste there that you have to deal with, and it's radioactive. So the new nuclear plants, believe it or not, take the old spent fuel rods and use them as a starting fuel, so they actually help clean up in the environment as well. So there's a couple of nuclear plants on the drawing board right now because nuclear is a very clean source of energy. It doesn't burn fossil fuels. Basically, that white plume that you see coming from a nuclear power plant, the cooling tower, is basically nothing more than water vapor. So nuclear is a very clean energy, very efficient energy. Oceanic engineering is big as well, as that's going to be another up-and-coming type of discipline. And agricultural engineering is going to be big. Companies like DuPont and Monsanto do a lot of work with ag chemicals. Another couple of facts, though, that are kind of startling. Believe it or not, about 1/3 of the people in the world go to bed hungry every night. I mean, we don't think a lot about that because, we get hungry, we go to Wawa, or we go to the refrigerator, grab something to eat. 1/3 of the people in the world don't have that kind of luxury. As a matter of fact, I just saw a stat recently that we in the United States throw away, the typical household throws away about 40% of the food that they buy and bring into the house. Something goes bad in the refrigerator, you just throw it out. Or, there's a big meal, there's a lot of waste at the end. But just think about that people are starving in this world, and here we are wasting food. Well, engineers are needed to try to help to mitigate those factors and figure out how to bring sustainable food to some of these countries. Another interesting fact, about half the world, believe it or not, fully half the world does not have potable water. Potable means drinkable water, readily available to them. We get thirsty, we crack open a bottle of water, or we go to the sink and we just take a glass of water. Many people in the world don't have that opportunity to do that. And just think, 2/3 of the world is covered by water, yet fully half the people in the world don't have potable water available to them. So I'm not trying to be a downer or anything like that, but these challenges, these things that need to really be fixed need engineers. They need STEM trained people to help us mitigate some of those problems in life that are out there. So that's why it's a kind of a cool environment or a cool career, is you're really helping other people by using your knowledge. So it's pretty cool. By the way, another engineering discipline which not many people know about, this is a branch of mechanical engineering. Somebody mentioned that before, mechanical engineering is called sports engineering. In sports engineering, and there are some schools in the United States, I don't know, I used to know the names of them, I forget exactly which ones they are, offer a curriculum in sports engineering. And in that curriculum, you get to design and develop and test sports equipment and do these other kind of things. And it's actually, like I said, a branch of mechanical engineering. So if you like sports and you like engineering, you might want to consider going into sports engineering. Some of the common technical paths which you can go into, I mentioned before, owner-operator companies. It's interesting, up here I have DuPont and Dow. I don't know if you heard recently, DuPont and Dow are actually merging with one another to form the largest chemical company in the world. It's going to be called Dow DuPont. ExxonMobil, GM, Eli Lilly, Monsanto. These are examples of what I call owner-operator companies. An owner-operator company is a company, think of that actually makes something. They make a product like chemicals or oil and gas or cars. It's called an owner-operator company. Another type of major segment of company is the type of company that I work for, which is an engineering consulting company. So I work for Jacobs, but here are some other engineering consulting companies. We don't sell products per se. We don't sell chemicals. We don't sell cars. What we sell is engineering services. We do projects in engineering for other companies because they don't have the capability of doing that engineering, or they don't want to employ the people to do that engineering, so they come to us and we are the engineering consultant. So these are the two major types of companies that an engineer could work for. There are others, but these are the major types. Some of the industries which you could go into, of course, are chemical, petrochemical, power, pharma, food, computers, sustainable energy, and these are just some of the industries that you could go into if you went into an engineering career. Some of the typical technical careers are, if you like to do research and development, you could probably get an advanced degree in one of the disciplines and go into R&D. You can go into corporate engineering. If you like to work with your hands or you like to be outdoors, plant engineering or field engineering are good choices for careers. You can be a discipline engineer, which means you'd be like an electrical engineer or a civil structural engineer, or you can even move into engineering management like I did and move into like project management or engineering management or a curriculum like that. So as I mentioned before, what I just talked about the last few slides are kind of your typical engineering disciplines, your typical engineering careers. But in addition to solving technical problems using science and math, there's many, many other careers that you can pursue if you have an engineering discipline. So, for instance, the first one here is if you like helping shape young minds, you can move into teaching. So I've done that. I have an engineering degree, but I'm also doing some adjunct teaching at Rowan University. I'm also hopefully helping impart some knowledge to you here today as well. So engineers can go into the teaching profession as well. So let's say you have an interest in the financial world as an engineer. You can go into economics or finance. I'll give you an example. Companies like Vanguard or Fidelity actually hire engineers to follow certain companies or sectors, as they're called, for their company. So as an example, Vanguard would like to follow the engineering and construction sector to find out how those companies may do in the future so they can decide if they're going to recommend engineering and construction stocks to their clients, or in their mutual fund, should they either buy engineering and construction stocks or should they sell them? Well, who better to keep an eye on the engineering and construction sector than an engineer? So you could work for Vanguard and use your engineering degree, but also be working in the financial world if you had an interest in that. Let's say that you like management. Well, you can do like I'm doing. I have an engineering degree, but I really don't do a lot of engineering. I really manage projects. So I'm in project management. Or you can go into some of these other management fields with an engineering degree if you'd like. Let's say that you like working with other aspects of a company and collaborating with others. You could go into something called strategic planning or process improvement. There's a company out there called Six Sigma. Six Sigma is involved with what's called process improvement. If you become a Six Sigma black belt, a company could hire you and they ask you to look at their processes to see how you can make their processes more efficient and lean them out, as they call them. In other words, how can you get more with less people? So if you like to do process improvements, you really have to be able to think outside the box here. You have to be a very creative thinker and be able to look at an existing process that the company has and make recommendations on how to make it better. Let's say you like working in the field, as I mentioned before. You could go into construction management or civil service, and these are some companies that do that. Turner is a very large construction management firm in this area. And of course, the Peace Corps is a civil service, and the Peace Corps does hire a lot of engineers and STEM professionals as well. Finally, if you like seeing yourself in a supporting role for project execution, you could go into project controls or sourcing and procurement. Project controls is cost, schedule, and estimating. Generally, engineers do this, and we're they wind up being in a support role for project execution by watching the costs and tracking the schedule and doing the estimating for that project. One final slide I have here on this is let's say you like to do writing and composing. Technical writers are in very big demand. Actually, if you have want to be a technical writer, it kind of helps, of course, to have a technical background. So as an engineer, you could make a very good technical writer if you decided that's what you wanted to do as a career. Let's say you really weren't sure and you like the engineering field, but you also like the law profession. You could go into something like patent law. Many patent lawyers have mechanical engineering degrees or civil structural engineering degrees, chemical engineer as well. Helps to have a degree in engineering if you're a patent lawyer, so you can actually do both. Let's say you like meeting new people. Let's say you do like the sales industry, you like to be in the salesperson. Well, technical sales and marketing for engineering products, it helps to have an engineering background. As an example, we have technical salespeople that come to us. They're selling process equipment, they're selling instrumentation, and they come to Jacobs and they try to sell us some of their stuff because they know that we specify this type of equipment for our clients. Many of these people are engineers, but they're also a salesperson. So again, they're acting in kind of a different capacity with an engineering degree. Okay, so here's the slide everyone likes to see. These are the average annual starting salaries for these various types of job careers. This was about a year ago, so they're not that much different. So it's the average annual starting salary. So in engineering, it's in the low $60,000 per year. It's a pretty good salary to start out at. Industrial engineer might be a little less. A petroleum engineer is going to be probably a little bit more. But if you took the average in the United States, you're going to be pretty much in that range. And these other careers, well, these are all great careers to have, but you can see their average starting salaries are somewhat less than engineering. Now, as I mentioned before, you'll notice computer science is another STEM industry. Math and science is as well. It's not as high, but these STEM careers, as I mentioned, there's a supply and demand gap between STEM graduates and STEM jobs, and that tends to inflate the salaries. So that's why one of the reasons engineering is so high. Also, I wanted to mention here, it depends on the location that you're in. Starting salary is going to depend if you're in the northeast portion of the United States, or if you're in the southern region, or if you're on the west coast. It's going to affect your starting salary to some degree. One of the things I like to throw in here too is the minimum wage in New Jersey is $8.25 an hour, which comes out to a little bit over $17,000 a year. So yes, engineering is not easy. I'm not going to fool you. I mean, you guys are in the Project Lead the Way curriculum. You're taking that curriculum because you have a real big interest in STEM. I mean, you could be taking an elective, I'm sure, that was a lot easier than what you're currently taking. And as you know, if you go to college for an engineering, I'm not trying to scare you away, but you're going to have to work hard. Engineering curriculum in college is difficult. It's a lot of work. It's a lot of studying. But notice where it gets you. It pays off in the end. Now, I do hesitate to mention that because I would encourage you not to go into engineering because it's top on the list here. Do not go into it because it makes a lot of money. Remember, you're going to be doing what you're doing for probably 40 or 50 years, or how long you're going to work. It's something that you really have to like doing. Engineering just happens to have the side benefit that it pays well, but I do encourage you, find something you really like and that you're really passionate about, and definitely channel yourself in that direction. One of the other things that we're lucky about in this area is within an hour drive, even at the most here, there are many, many excellent engineering universities. Rutgers, Rowan, UOD, Drexel, Villanova. I mean, these are just some of them, okay? As you know, we're very lucky here. You could go to these colleges. You can not be very far from home if that's what you'd like. Some of these are state schools, so they're very affordable. I don't know if you heard about it recently, but Rowan has a new program for incoming freshmen. I believe it starts next year in the 2016. If you're coming in and you agree that you'll go in the summer, You can finish your 4-year degree in 3 years. This is at Rowan. And Rowan will pick up the tab for your tuition and your room and board for those classes that you take over the summer. So basically, you finish 4 years in college in 3 years, and it only costs you and your parents 3 years. It estimate you'll save about $22,000. And Rowan is doing this for a couple reasons. One of the main reasons, though, is they're trying to peak shave and get more students to come in the summer. Because their summer curriculum, their summer enrollment is very low. So they're actually giving away free tuition and room and board to encourage incoming freshmen to finish in 3 years. Plus, you get done earlier. So you're not in school for 4 years, you're in school for 3. You get to start your career sooner. So that's kind of cool. The other thing with Rowan, as you probably know, is Rowan has already started to build a new engineering building right next to its existing engineering building at the campus in Glassboro. They want to double their engineering enrollment by the fall of 2017. So that's kind of good for me as an adjunct there. They're going to need more adjunct professors, so I have hopefully a good chance of staying with them there. Matter of fact, over the next couple of years, I would like to move out of what I'm doing at Jacobs and move more into teaching at Rowan. So Rowan's really expanding. They're a very forward-thinking university, and hey, I'm not pitching them because I work there. I really have no need to tout them, but they really are doing a wonderful job. They're also building a new business college that's about a third of the way built there now. So lots going on at Rowan. Nationally, these are some of your larger engineering schools. You've heard about a lot of these, like MIT, Cornell, very prestigious schools, very expensive schools. Geez, I don't know what a Cornell, what 1 year Cornell goes for. It's got to go, I'm guessing, maybe 50 grand a year or something like that. Very expensive. Whereas a place like a Rowan, a Rutgers is probably going to be really almost half of that. So, I mean, you really have to decide, you really feel you're getting the bang for your buck here, because an education at these universities is highly expensive. As I mentioned before, I'll leave this presentation with Mr. Knaus, but these are live links, and if you call this presentation up, if you just click on these, they'll take you to the website, and these may be some topics you might be interested in, and you could look at these a little bit further on at your own leisure. And that's basically what I have today, folks. I'd like to answer any questions that you might have about either careers in engineering or the engineering industry in general.
Anything? Sports engineering. What about it?
I'm sorry?
Do you have any more information on sports engineering?
I can get you some. Like I said, there are some schools. They were not New Jersey. I remember that. I'll get you the names of the schools. They actually offer that as a bona fide curriculum. As I said, it's a subset of mechanical engineering. I'll get you the names of the schools, Mr. Knaus. I'll send it to you, and you can pass it along. But yeah, it is kind of a cool curriculum. You're basically a mechanical engineer, but you're working with different types of sports equipment. Think about as an example, this issue about concussions for football players is a very big issue, and they're always trying to improve helmets and make them safer for professional and college and high school and even the Pee-wee football players. So as a sports engineer, you would actually be working on things like that, how to build better baseball bats, or how to build better football helmets, safer football helmets, and things like that. So I'll get you the names of the schools, and I'll send them along.
You want to learn more about business? Engineering, business. Can you go into a little bit more detail about the business and how engineers evolve in the business industry?
Yeah. So. As I mentioned before, if you say you had an interest in the business field, but you're an engineer, as I mentioned, the predominant discipline for CEOs in the Fortune 500 is engineering. So they're basically, a CEO is basically running a company. They're in the business field. They're working on how to improve their company, how to make their company better. So engineers actually have a very good skill set for that, because we are usually taught troubleshooting techniques. We're usually taught strategic techniques. We're taught brainstorming techniques, and all of those skill sets are very valuable in not only the engineering industry but also the business and finance industry as well. So you do learn some skill sets which make you very valuable to the business field. So engineers a lot of times are go into the business field. Another example, that's one of the reasons that I got an MBA or a Master's in Business Administration, is way back when I got my engineering degree, I also wanted to have some formal education in business, so I got an MBA. Nowadays, they have a curriculum called engineering management. Engineering management, think of it as kind of like an MBA for engineers, more or less. And basically, you're schooled in the business aspect and the management aspect of engineering by taking an engineering management curriculum. As an example, Rowan has a Master's in Engineering Management curriculum. It's 10 courses, and they're all online. So you can take it as an online curriculum, and you don't even have to go to the college, and you can wind up with a master's degree in engineering management. So having an engineering degree and moving into the management or business field is really a good background discipline to have because of the skill sets that we learn as an engineer.
Describe your experience working with sales reps or salespeople in business with a business degree versus an engineering degree. Like, what's the difference between a salesperson with a technical background versus someone who has a business background?
Yeah, that's a good question. So, as I mentioned, we at Jacobs, we work for other clients. We work for the refineries and the chemical plants in the Delaware Valley area, as an example. So we specify a lot of pumps. We specify process equipment. We specify instrumentation. We don't buy it, but we specify it for our clients. And then our clients buy it. So the sales reps come to our office because they know we specify it, and they want us to recommend their product. So they figure if we can know a lot about their product, we build a relationship. We're more apt to specify their pump or their control valve or whatever. So when you talk to these people and they come in, you can almost immediately tell who are technically schooled and oriented and who are not. The reason I think it's probably better to work with someone who is technically oriented is you can ask them directly very technically oriented questions about, say, a pump or a piece of instrumentation or a piece of process equipment. And since they do have a technical background, they generally will engage a dialogue with you about the technical aspects of that piece of equipment. Whereas someone who really is just in the business end of it and they're really just a salesperson without a technical background, they might say, well, that's a good question, I'll have to get back to you, I'll get one of our technical representatives to get back to you, and you kind of lose the continuity there. So I think when you find out that these people do have a technical background, it does make the conversation a lot easier. It makes the conversation a lot more transparent and a lot more sustainable. So a lot of those folks do have engineering and technical backgrounds who rep these various companies that sell technical equipment.
Yeah.
Self-study university improvement, would you recommend Drexel or Rowan?
He's basically asking, like, as universities are improving, is there any university that you would recommend for certain degrees? Would you say, like, for instance, would you recommend like Drexel for a chemical engineering degree, or would you say they're all about the same?
Well, I went to Drexel and I teach at Rowan, so I have to remain unbiased here. I would have to say personally, for that level school, a state school. I'm not talking about the Cornells and MITs of the world. I'm talking about your state schools, your middle of the road schools when it comes to cost. It's pretty much the same, I think. I mean, if you go look at the chemical engineering curriculum across different colleges and universities, the courses that you take, the coursework is really almost identical. So a lot of it depends on, of course, the professors that you get. like when I do the teaching that I do, I try to bring a more real world perspective. So I try to bring the students what we're supposed to cover, if you will, the book smarts. But I always bring some real world aspect almost to every class that I teach, or at least I try to. Another example, though, to answer your question is just as an aside. I started out at a community college. I started out at Burlington County College back in the 70s. I started there in 74 when BCC was really just starting. And because I didn't really know what I wanted to do. So I didn't want to go to college and take up something, and it was kind of expensive at the time. It was relative speaking, but I figured, let me go to a community college and feel my way around a little bit and get a lot of my gen eds out of the way, the general education requirements. Back then, believe it or not, a course at BCC was, I think it was $25 or $30 per credit. So you could take a 3-credit class at BCC. This is back in the 70s, for less than $100. So I took I got a 2-year degree in chemistry. They didn't offer an engineering curriculum back then. They do now. They didn't then. So I took chemistry, and I decided, I want to go into chemical engineering. My father was a chemical engineer. So I kind of had an idea that's where I wanted to go, and I transferred to Drexel, and I went to Drexel at night, and I worked during the day to get some experience. I also got a lot of my education paid for because the company I was working for had tuition reimbursement. So that's another benefit. It's not an easy way to do it going at night, but it does have some side benefits. You get a lot of experience, and sometimes you can get your career paid for. So, matter of fact, both of my sons, one of them is a civil structural engineer, and one of them has a business degree. Both of them went to community college first as well. One then transferred to Drexel, one transferred to Wilmington University. So, many different ways to do it. I think the thing at Rowan, again, I'm not pitching Rowan, but the thing where you can finish in 3 years, I know I wish that was available when I went to school. I think that's very cool. You get some of your education for free, and you get done in a really short period of time, and you can hit the ground running, and start your career. So, but to answer your question specifically, it would be hard for me to say, this chemical engineering program at this school is better than, that chemical engineering program. I think you're going to find they're pretty much the same. So you might want to consider other things like the school environment, extracurricular activities they offer. Do you want to live near home? Or, some people don't want to go to school around here because they want to really get away from home. They want to get out on their own and, really experience, what it's like to be out on your own and in the real world. So, I would consider some factors like that when you're thinking about where to go to school.
Else?
That summer program at Rowan, does you know if it's if you qualify or just sign up?
The question came up about the summer program at Rowan. Do you have to qualify for that, or you just sign up and they just kind of put you in the on the roster for it?
You mean qualify in the way of like financial qualification?
Or like, okay, say you're in the engineering program at Rowan. Do you have to apply for the summer opportunity, or if you just say, hey, I want to do it, you can do it?
I think you can just do it if you say you're going to do it. You do have to commit to going though, so you can't say, well, yeah, I'll go to summer, and the summer rolls around and you're like, well, I don't want to go. You do have to commit to it. My understanding was there really wasn't that many restrictions on it. Now, if they get a flood of applicants, they're probably going to have to maybe take some kind of selection process. But my understanding was it was pretty much open to whomever wanted to take it, and there were not a lot of restrictions to my understanding.
And this is only for people in college,
Is it only for kids in college
Versus,
people in high school?
versus like a high school articulation thing?
yes, it's for college students. Yes.
Like what you would want to do, you would do through Rowan College, Gloucester County College, like between your junior and senior year, and that's where we'll get you like some gen eds or something out of the way.
So another thing that, speaking of RCGC, what they did recently, some of the students who were going there were complaining that they knew they wanted to go into engineering, they wanted to start a community college, so they were at RCGC, but they didn't really know which courses they needed to take to, let's say, transfer into mechanical engineering at Rowan's main campus. So what Rowan did was they set up specific curriculum now at RCGC that if you know, say, you want to go into mechanical engineering, you take these courses. It's very specific, and all of them, obviously, if you do well, you have to do well. They all then would transfer to the large institution in Glassboro directly, and you just hit the ground running your junior year at the main campus with the 2 years out of your way. So they've actually made it simple for you if you know what you want to take. They tell you these are the courses to take. They all transfer, providing your grades are good, and away you go. So Rowan is really trying to make it with that and the 3-year thing I mentioned, the fact that they're expanding their engineering college by doubling it. Rowan is really trying to cater to the engineering community here by all of these creative solutions that they have. And I think, they're doing a great job of it. I mean, they're expanding down outside the main campus. If you go down the Route 55 there and 322, if you've ever been down there, they have the technical center that they're going to be expanding. That's part of Rowan as well. They now have a medical college, Rowan Medical College. So, I mean, it's really a very forward-thinking university. Again, I know it sounds like I'm pitching them because I work for them, but I mean, they really are doing a lot of really cool things. So it's a really neat place to be.
Okay, I think we have to get the students out for dismissal. So,
Okay.
thank you so much.
Thank you.
My pleasure. I hope everyone enjoyed it. I will get Mr. Knaus the names of the colleges in the United States for sports engineering. And if you have any other questions, Mr. Knaus has my email address. Feel free to email me. I'll be happy to answer your questions.
All right, thanks so much, Rob.
Okay. Take care, guys. See ya.
Okay. Casey, do you need a pass? All right, I will forward the names to like Mr. Reed and Mr.